Okay, today we're going to talk about the electrical system in the fast foaming cart portion. We're going to start off with the power cord. The power cord, its most important feature is this GFCI. It stands for ground fault circuit interrupter. And basically when you plug this into the wall, you have to engage the power by pushing this red button. When you do that, you'll see a green light come on. Now you know that you have power going through the complete power cord, and then we're going to end up plugging this into the cart. There's a male locking plug at the cart panel, and we lock that in place, and now the cart has electrical systems. Each end of this cord has stress boots on it. One at the plug here. There's two on either end of the ground fault circuit interrupter itself, and that's to minimize the damage that can happen from the flexing of the cord at the stress points. The cord itself is what they call a 12-3. It's a 12 gauge 3-wire cord. It's got a neutral line in it, a black load line, and a green grounding line in it. And every time that electricity flows from one system to the other, you have to start with the largest gauge first, and that's why this is a 12 gauge. We're going to bring in the tether here shortly, and that's a 14 gauge, which is a smaller diameter cord than the 12 gauge. So this cord then that green light will only go away when you unplug it from the wall or something in the system trips it, and then it will go to a red line letting you know that something was wrong, and that's why it disrupted the power flow. So let's get rid of this. The tether. So the tether, just talking about the electrical system now, we've got two plugs on the tether, and one is a female locking plug and one is a male locking plug. And again, these have to be locking because we have a liquid and an air line at both ends of these plugs. So if any stress gets on this tether, the cord has to take the load. If not, and we pull hard enough, this solution line will come dislodged from the end, and liquid will go spraying everywhere on this tether. So that's why those have to be locking plugs. The cord itself is the safety mechanism to keep that from happening. Having said that, if you do pull on the cart with these tethers, they are going to break. They're not designed for doing that. They're just designed to keep things in place. And 90% of the time that there's an issue with this tether, it's usually this female locking plug that plugs into the cart itself, and then once in a while it'll also be this male locking plug that plugs into the CRB machine, but usually it's this female one. And as soon as that gets replaced, everyth's okay. If that's not the case and we want to test this out, we can remove this, and I've got a voltmeter, and hook it up, and then we can run this voltmeter all along the tether itself, and if it quits beeping with the red beeping sound and that red light, we know there's a break there. And depending how far down that break is within the cord, we can either repair it or the electrical line itself will have to be replaced because it's too far into the cord to make a repair. The other thing that we've done is we've wrapped this cord in a 6/6 20 mil nylon wrap, and this makes it very slick, and it also, when you're pulling it along where cue balls are and all that, it's designed not to get hung up underneath doors or around the corners. It's designed to slide around there. Plus, it's very durable with that 6/6 20 mil on cuts and abrasions, so that helps this cord being protected. So the next thing we're going to look at is the panel itself. Now I've taken a lot of things off the front and the back of this panel just to, again, isolate on what we're doing from the electrical system. So we're looking at the male locking receptacle. This is where the main power comes in. There's a circuit breaker that's right above it. It's a 20 amp because you might be running more than just your CRB machine off this panel at the same time. You might have a vacuum cleaner plugged into the straight receptacle over here, and it's also going to be pulling some electricity. So we're going to be maybe really close or north of 15 amps. That's why we need a 20 amp on this side, and we're down to a 15 amp when it comes to where we might plug in, again, a vacuum cleaner, a little handheld extractor, a fan, something other than the scrubbing machine itself. We come over to where the scrubbing machine is going to be plugged into, and it also has another circuit breaker designed for 15 amps, and this is where the male locking plug will plug into the car panel. There's a toggle switch on the front. Down is off, which in this case I'm holding this upside down, so this would be the on position, and then that would be the off position, and that's going to interrupt the circuit for the neutral line, which is going to be a white line coming off the back of this down to where the air compressor and the fans are at. So again, I've taken a lot of different wires and everything off the back of this so that you kind of see the progression of how the electricity is going to work. And so if there's an issue with electricity, they have a lot of these quick disconnects that wires, just like here, can become disconnected, and it's really easy to reconnect them because it'll have this disconnect on the end. You just plug it back in and you're good to go. So you can look up underneath there to see if you see any issues with hanging wires that look like they're not where they're supposed to be, or they haven't been plugged in. So in my example here, so this one's come loose. It's a plug. It's got a electrical pin on the outside, and I can see it's not attached anywhere, and I can say, oh, where's that supposed to go? And I know it's supposed to be over here, so I can reattach it in the hole, tighten it back up, and now our issue's been resolved because a line just came dislodged from the back of this panel. Okay, so that's the panel part. Next, it's a little bit more complicated. I need to move everything over here for a second. So we have the air compressors that are being fed electricity from the panel. There's two fans. I'm going to tilt these up so you can kind of see what they look like. This is the back of what the fan looks like. They're from Dayton. And then the front that would be facing outwards towards you would very much look the same, other than it doesn't have the logo on there. And you'll notice there's two lines coming out of each one of these fans. So these are what they call AC fans, so it's an alternating current, so there is no load or neutral line. You can intermingle those lines however you want, but you don't want to take both lines off of one fan and connect them to the same outlet. You have to have one fan line going to a load and one of the wires going to a neutral. So that's what I'm going to show you, what we've done in this diagram here. So I'm going to lay these down for a second so you can see that. The air compressor itself has four lines coming out of it. There's two black ones, and they feed over to this run start capacitor. And again, it's a quick disconnect, so they just plug right in. It's got a rubber boot, then you can cover the electrical components to help those where they don't come dislodge or anything comes in contact with them that you don't. And then you've got a brown line and you have a blue line. The brown line is going to be our hot line. That's going to go to a black line coming from the control panel. And the blue line is going to be our neutral line that also is coming from the control panel. So I'm going to kind of hold these up as best I can. So this line, if you can imagine, this white line is coming down from the control panel. It's going to go over to the blue line from the air compressor. And I'm going to take those two wires and a wiring nut to connect those. This line is going to go up to the toggle switch, and I can either interrupt the electricity or let the electricity flow at the toggle switch, which is going to turn this air compressor on or off. This black line is coming from the control panel also, and it's what they call the load line or hot line, and it's going to go with the brown wire to the air compressor. And again, there'll be a wire nut that goes on to this, and that always is in the on position. We turn it off by interrupting the neutral line, not the load line. Same thing with the two fans. So now we have one of the wires to the fan is going to go to this load line, and one of the wires from this other fan is going to go to this load line. So you've got one wire from each one of the fans. We've got the black line coming from the top of the control panel, and this brown line for the air compressor all get twisted together, so that completes the circuit here. The fans now, they're going to run all the time. They're not going to be interrupted, so they're not going to the toggle switch. They're going to always on load line, which is a white line coming off the control panel. So whenever you attach electricity to the panel itself, these fans automatically turn on and they automatically turn off once you unplug it. They run continuously when there's a power supply to the cart itself. And then the same thing with this one. We've got a locking plug on that, so we put a wire nut on this, and all this now is ready to go from a wiring standpoint. Now and again, they'll go to turn on the unit and the air compressor doesn't turn on, and it may not be an electrical problem. What will happen is if you've got, there's a needle valve that controls the airflow. It's right behind the air coupler at the cart, and if that is turned too far down or all the way off, it doesn't allow enough air to come out of the air compressor, so it locks it up, and the motor will hum, but you won't hear it running because it's there's rest from that lack of airflow. So in order to make that go away, all you have to do is go counterclockwise on the needle valve that's up underneath the control panel, again right behind the air coupler, and that'll release the pressure and allow this air compressor to start up again. So that's it. It's pretty simple compared to the CRB machine, but that's the electrical system. You can test things by using the power cord, for example. Again, if you think there's you can't get the CRB to start running and it's hooked to the tether, just undo the tether, hook the power cord right up to the CRB machine, and then see if that doesn't fire it up. If it does, then you know that your electrical issue is either in the panel or it's in the tether, but it's not in your power cord and it's not in the CRB machine. So that's one way that you can test to see if you've got an issue with it. And again, we've got these voltmeters where we can look for lines that may not have power to them, they're supposed to, because the wires come off a quick disconnect, or there's a cut from abuse of the equipment. If you notice I'm going to show you how this is wrapped up. See how this is wrapped up in a nice round shape? So that's kind of how you want to store things. We have hangers on the back of the CRB machine, and it goes over the cart. You've got a hook on the back of the cart, and you can put this on the cart, and that'll keep it from getting miswound. If you do that, sooner or later, it's going to look like what they call pigtailing it. And you don't want that. You'll start getting internal breaks in the wires from not wrapping it up the way it's supposed to be wrapped up. Same thing on this tether. Move this stuff out of the way. It'll be a nice, smooth, round loop, not twisted around. And again, there's hangers on the back of the cart itself that you attach it to. And as long as you wrap this properly all the time, you shouldn't get any breaks or snaps in the electrical line inside. If you don't do that, you'll start getting twists and all that, and eventually one of those neutral or load lines that are inside of this tether are going to break, and then you're going to have to replace the tether. So a lot of this information is in the owner's manual that'll have still shots, and it'll have verbiage of everything that we just went through on this video, so you can use both resources in order to diagnose what your issues are or fix the different electrical components of the foaming cart itself and of the CRB.